Hello, Math 125 fans. Going to finish up this discussion of integration. Here, I just like to talk about what do we do when we're stuck. So we're going to talk about substitution, simplification, and then do a very quick summary of those methods. I know these videos have been a little longer, but very important collection of skills, and I hope I've given you some of the key ideas in case you missed them. You're the first go around in your classes. So here we'll do a couple problems, and then I'll pull up an old exam or two, and we'll peek at a few things. Okay, so when I look at this, I go, it looks like a trig, but it's messy because of this inside here. This is a very standard situation. We call this a rationalizing substitution. I tell students if you're at the beginning of a problem and it looks messy, rather than using U, I suggest you use T. Now there's a reason I say that, but you can use any letter you want. You can use U, there's nothing wrong with that. But I'm going to do this substitution. It is not obvious that that's going to work when you first see this because there's nothing on the outside for it to cancel. There's a separate thing, which is it is way easier, not way easier, it is slightly easier if you rearrange it before you take the derivative. You can take the derivative directly, and then you can talk. I could talk for a while about what this derivative is. I'm just going to skip right to it. But that gets sort of messy. You get square root of x, dt is dx. But you can get there in one step by writing 2t dt equals dx. So since this happens enough, it's nice to know this maneuver. You might say that's different. No, well, that's t, so it is the same. Okay, so let's play this game. So now we're going to change everything but the squiggle. The only thing that stays the same is the squiggle. That's not a math term, that's my own term. I'm changing the bounds. Students get really mad sometimes when I change the bounds. Like I have committed a crime against humanity. I think it's because in high school maybe they had someone say don't change the bounds. But I have a long view for my students, which is many of you are going to go on into future math courses, Math 224. Changing bounds becomes really valuable, even if it wasn't before. So, and it doesn't take any work. You just have to plug in a 0 there. The square root of 0 is 0. You just have to plug this in here. So what is the square root of pi squared over 16? So don't get mad at me for doing this. I have students say, what if I don't do this? What if I don't do that? What I see a lot is people don't change and then they forget and then they get the wrong answer. That's what I'm worried about. But if you change it, the rest of the problem is going to be easy. Okay, now we need to replace dx. It's 2t dt. Now we're doing this problem instead. We're actually changed the geometry fundamentally. And these two areas are the same. It's technically incorrect if you put pi squared over 16 on top. Okay, enough of that. So now what do? It's a product. So now we've just happened onto a problem we know. We're going to do integration by parts. Yet another chance to do this. And try to avoid using the word and in an exasperated way because students say, I have to do substitution and integration by parts. That and is what gets me as an instructor because I'm like, you can do it. You can do it. Just compartmentalize a little bit. We're integrating here, so it's going to be negative cosine. Put those two together. Put those two together. Let's do it. Let's smoosh them together, as I like to say. A cosine of t, evaluated from 0 to pi over 4, minus, we're going to smoosh these two things together, negative 2 cosine of t dt from 0 to pi over 4. Because I changed the bounds, there's no need to switch anything back. That would be a waste. So we plug this in, we get, and let's simplify as we go. So if we plug this in, we get negative pi over 2. And students are really reluctant to do this, but if you can just simplify a little bit as you go, it makes your life so much easier. If we plug in a 0, we get a 0 because of that. So I'm done with that part. Plus 2 because of the minus. This is where you can see that I'm consciously slowing down here. You should, through doing the homework, you should know where the errors are sort of likely. Slow yourself down there. Okay, we're going to integrate. It's sine of t from 0 to pi over 4. So what am I getting? The first one is pi root 2 over 4 plus 2 times root 2 over 2. So there's so many ways to write that. I feel like I want to leave it. I also feel like I want to factor out a square root of 2. I also feel like I want to rearrange it. I also feel like I want to factor out the 4. Not all those are right. Let me look and see what I wrote here. Yeah, I wrote it like 5 different ways because I knew students would ask me about this. There we go. Hope that is of help. Let's look at another one. I was trying to think of what are some of the ones that students have told me were the hardest. This is a fairly standard one we just saw, a rationalizing substitution. If you see a square root of x, do that. Okay, this one just looks weird. And I admit that it looks weird to me too. And the moment it looks weird to me, I know substitution will help me. Sometimes there's problems where there might be another like clever way, but substitution is always a good idea because it gives you a new integral to think about. Think of a substitution just as transforming the problem into something else. And no matter what, that's a success because now you have 2 things to look at. And then you can try another substitution. Then you have 3 things to look at. And eventually, if you keep doing that, you're going to happen on something you know how to do. Now, the thing is, on a test, you don't know if you're going to be able to do that in the time limit. I understand that stress. Okay, so to me, the only logical choices here are e to the x or e to the x plus 1 or the entire thing. Like, to me, I don't know what else students would be doing on this problem than writing one of those first 2 things with maybe a u. Now, based on experience, I usually like to pick the entire denominator, but let's try that. But you could do the other one. I'm certain it will work. Okay, so now we need to get dx. Dx is 1 over e to the x. You can see how it just gives you comfort to know you have a plan in all situations. Okay, let's change everything but the squiggle. When you plug in a 0, so I've decided to do this one. You plug in a 0, you get e to the 0 plus 1, which is 2. And then when you plug in a 1, you get e to the 1 plus 1, which is e plus 1. Okay, that's done. We get 1 over t. That's done. We get dx is 1 over e to the x dt. That's done. So that's all really automatic. You just have to do it. Okay, this is something that happens sometimes, that after you do a substitution, there's still a t floating or an x floating around. And if you need to get rid of it, you go back up here. That's a standard maneuver back from section 5.5. So e to the x is what? Well, it's t minus 1. Oh, so that's t minus 1. The integral from 2 t plus 1. And to me, well, let's do it in 2 steps. T minus 1. Why did I write it that way? I don't know. We have 2 fractions next to each other. Let's write it nicer. 1 over t minus 1. Done. So again, the whole point of the substitution, if you haven't caught on to this yet, is just to give you a fresh integral. Substitution itself doesn't solve the problem. It just gives you something new to think about. I like that one, though, because that hits on one of our topics, partial fractions. T minus 1. And I encourage you to go through and find a and b. I can tell you right away that a is negative 1 and b is 1. If you want to know how I did that so quickly, it's the cover-up method. It's a shortcut, but it's really fast to clear the denominators as well. Okay, so anyways, this is going to be the integral from 2 to e plus 1. The shortcuts I'm on this partial fraction, it really isn't that valuable until you get to Math 207. And so I always teach students every shortcut I can there. But even with those, it doesn't prevent you from needing to know the method. Okay, so this is negative the log of t plus the log of t minus 1, evaluated from 2 to e plus 1. Looks like I'm probably off my screen now. Then we plug everything in. So this problem that was really hard, or appeared to be hard, maybe isn't so much. Because to me, it's clear we have to do substitution. Because when I looked at it, I'm like, I don't know what to do. And the moment I say that to myself, I go, substitution. That's a 1, that's a log of 2, so it just depends on how you want to write this. Negative the log of e plus 1 plus 1 plus the log of 2. Yep, that matches my solution. Success. Okay, so let's play one game. Let me make this smaller. Sorry, I didn't have this ready. One quick game here, and I am organizing my videos. I'm trying to make this look better. I hope this is helping. I need help if someone knows how to make websites. Okay, we'll go to Math 125. We'll click on an old exam, and this game is really easy to play. And the game I'm talking about is clicking on a random old exam and saying, how would I start that? Oh, we just did that. Substitution. There's a square root. Trig sub, partial fractions, trig sub with completing the square, integration by parts, trig, done. You can do this easily in a few minutes. You say, well, what about the ones I don't know how to start? Then you make a note of those and you go back to them. We know how to do that one. Partial fractions, trig, pull out a secant squared, substitution, trig sub. There's the one we just did, substitution, trig sub. Making sense? You can also look at old finals. We need to get to a point where it's kind of second nature. And also, I have many practice pages here. 30 old integrals with answers. Partial fractions, by parts, trig sub or regular substitution actually works. By parts, trig, partial fractions, trig, partial fractions, trig sub, partial fractions, substitution. So you can play this game. And I've tried to make review sheets of different types. Like, here's how you start. Here's how you actually work through it. This is just, you just got to put in the time. All right, hope you are finding this helpful. Let me know with a like or a comment if this sort of stuff is helpful to you.